Okay, we're going to take one more look at these optimization questions. Again, our first example, we have this box that we're constructing. We're going to cut out the corners. We want to figure out what would be the maximum volume. Okay, we're going to start off with the formula for the volume of a box. The volume is going to be the length times the width times the height. Okay, the length would be all those green lines right there. You can see that x plus the length plus x all adds up to 70. So we have x plus the length plus x equals 70. Of course, x plus x is 2x. And subtract 2x from both sides. And there we have our length, 70 minus 2x. Okay, we're going to do the similar thing for the width. The width would be all those red lines right there. And you can see that x plus the width plus x all adds up to 35. So we do a similar calculation, and we get that the width is 35 minus 2x. And the height would be any of those blue line segments, so you can see that's pretty easy. It's just x, so the height is just going to be x, and that's the equation that we want to maximize. Okay, let's go ahead and type that into our graphing calculator. Okay, we're going to go to our y equals screen, and we'll type it in y1. Now you don't have to put a multiplication between 2x. It knows that it's supposed to be multiplication, but everything else you should put a multiplication there, or else you might get an error message. Now that we've typed in the equation of y1, we're going to go to the home screen. We want to solve where the derivative is 0. Again, we get a bunch of answers. If you look at the smallest side, we see that it's 35, but we're cutting out corners from both sides. So our x has to be strictly less than 35 over 2. We also need our x to be greater than 0, or else there will be no height. So we need to choose critical numbers that are between 0 and 17.5. So the 27 is no good, it's too big. So we're going to choose 7.396. Now if I wanted to find the maximum volume, I would plug that critical number into our volume formula. Remember we saved that in y1. But here it's just asking what height x would give us a maximum volume. So we're done. Our final answer is x equals 7.396. Okay, here it's asking what point on the graph of y equals e to the x is closest to the point 0, 2. Now this red point right here is going to be the point xy, and we're going to need to use our distance formula for the distance between 2 points. Let's plug in our 2 points. Now this is supposed to be a function of x, but there's a y here, so we need to fix that. We can trade the y for e to the x, and that's the formula we're going to minimize to find the minimum distance between those 2 points. So let's plug that in our graphing calculator. We're going to plug it into y1, then we're going to go to the home screen, and we'll solve where the derivative is 0. Okay, it's given us 2 answers. One of the answers is some weird equation to find the answers, and the other one is x equals 0.524. Now we have the x value of the point that is closest to 0, 2 that's on the graph of y equals e to the x. But we don't have the y value. So we're going to have to plug this x value into the function y equals e to the x, and then we'll be able to find the y value. Remember, we want to use as many decimals of accuracy as possible. So from the home screen, I'm going to type in e to the x, and my x value is going to be that entire decimal. So I'm just going to go up and grab it, and I'm going to delete everything in front of that decimal. So I'm going to delete the x equals and that weird equation. Now I want you to notice that if you grab the whole decimal, it does give you some extra accuracy. So instead of just being 61 at the end, it's 6071. So we can fix that. So now our final answer will be even more accurate. Most of the time it doesn't make a difference, but sometimes it does. Okay, final answer for the y value is going to be 1.689. You could also use y equals 1.690, but make sure you include the 0 if you do that, because the 0 means that it's a rounded number. Okay, there's our final answer at the bottom. Okay, it says the sum of the cubes of 2 positive numbers. So my positive numbers are going to be x and y. And then it says is 800, so that's equals 800. And it says find their maximum product. Their product is just going to be when you multiply them together. So x times y is their product. Now I need to solve this equation for either x or y. My product function is going to be a function of x. So I'm going to replace the y with some function of x. Let's solve this one for y. Got to take the third root of both sides. And now you can replace the y with all of this stuff right here. Okay, there we go. Now we have our product function that we can maximize. Okay, let's go type that in our graphing calculator. We're going to type it in on y1. Don't forget to put multiplication in between x and that third root. Remember, the third root is a power of 1/3. Now we're going to go to the home screen and solve where the derivative is 0. Okay, we're getting 7.368. Okay, all we found was the x value where their maximum product occurs, but we have not found their maximum product. It wants us to find their maximum product. So we're going to plug this x value into the product function. Remember, we saved that in y1. So from the home screen, we can just do y1 of that critical number. So I'm going to type in y1. I leave my cursor there, and then I go up. I grab the entire number, and you'll notice it gives me a few extra decimals of accuracy. So I just need to erase the x equals in front of it. Again, you'll notice it just says 28 at the end up here, but over here you get 2807, so you get a little bit more accuracy. Okay, after plugging it into my product function, I see that the maximum product would be 54.288. And that's it. That's our final answer. That would be their maximum product. Okay, this one says, what point on the graph of y equals 9 minus x squared would give you a maximum area for the box? So we're assuming that our x value is between -3 and +3. So first we're going to write the area of this rectangle. Area is going to be length times width. The width is just going to be the distance from here to here, so that would just be y. The length is going to be this entire distance here, but we know that from 0 to x is a distance of x. Now, because this is an even function, the distance from 0 to this endpoint is also x. So the entire length is going to be x plus x, so that'll be 2x. Now my area function is going to be a function of x, so I can't have this y here. So I'm going to trade my y for 9 minus x squared. Okay, you don't have to, but if you wanted to, you could multiply everything out. You just distribute the 2x on each piece. And that's the equation that we want to maximize. So we're going to plug that equation into y1. Then we'll go to the home screen and we'll solve where the derivative is 0. Okay, it's giving us two answers. We want our x value to be between 0 and 3. So we're going to throw away the negative answer. So when I write my critical number, I'm only writing 3 decimals of accuracy. But if I ever use that number to make more calculations, I'm going to try to plug in every single decimal of accuracy that I can possibly get. This question is asking for the point on the graph. I already have the x value of the point. So to get the y value, I'm going to have to plug it into the original function. One way to do that is you can type that function in y2, and then we'll do y2 of our critical number. We're going to need to go to the home screen to do that. Again, I want as many decimals of accuracy as possible, so I'm going to go up, grab the entire number, and then I'm going to delete the stuff that I don't need. Don't forget to delete the x equals. Okay, it looks like our answer is 6. You'll see if I go up and grab that number, it's actually 5.99999, so it looks like it rounded it for us. So I would either put 5.999 or just put the 6.000. Either answer would be acceptable. Now the only thing I want to add before we move on is that I do recommend that you use the area formula that's right here in the box. And the reason is that if you distribute the 2x incorrectly, you're going to have mistakes, plus you're going to waste time doing that distribution. So don't waste your time and don't risk making a mistake. Just use the area formula that you see right there in the box, and you'll probably be more successful. Okay, you can see they give you the cost function up here, and they want you to find the x, which is the product level, such that the average cost is a minimum. So our average cost would be the cost divided by x. We call that C bar. So this is a pretty simple one. We're already ready to type it in our graphing calculator, and we'll minimize that function. Okay, we're going to type it in on y1. Then we'll go to the home screen and we'll solve where the derivative is 0. Okay, it's giving us a couple answers. One of them is negative. Remember, you can't have a negative x value that doesn't make sense. So we'll just take the positive one. Then it says, what is that average cost per unit? So we're just going to plug our critical number into the average cost function. Remember, we saved that in y1. So from the home screen, we can just do y1 of our critical number. Remember, we're just going to go up, we're going to grab everything, and then we're going to delete the stuff that we don't need. Again, don't forget to delete the x equals. And I want to point out again that you get more accuracy that way. Instead of it ending with 7.4, it's ending with 7.358. Okay, that average cost per unit is going to be 7.7859. I prefer to truncate it. Again, it's okay to have that third decimal, even though it's money, because remember, at the gas station, they do charge you 9/10 of a cent. Okay, I also want to point out that you have a decimal answer for x, but sometimes you can't make that many. Sometimes it has to be an integer amount, like let's say you're making TVs. You can't make 0.994 of a TV. So in that case, you want to check 1290, and you want to check 1291. Remember, we're trying to minimize the cost. So you would just check the cost at each of those values and see which one is smaller. So for this example, we're assuming that you can make a decimal amount in terms of product level. So that's your X value that we're going to use. And this would be the actual average cost per unit if we made that many of them. Okay, here it says find the area of the triangle with the least area in quadrant 2 that goes through the point -5, 2. Now, if you look on the right, I'm showing you an alternative way of doing it. The area on the left would have the same thing as the area on the right. So that might be easier to actually calculate. Remember, all they want you to do is find the area. So the triangle on the right would have the same area as the triangle on the left. But let's go ahead and actually do this one where our x value is on the left. Remember, our x is going to be a negative number. Again, the area of a triangle is just going to be 1/2 base times height. For our base, we're going to use the bottom. For our height, we're going to use the right side here. Remember, the length of the base is going to be the x-intercept of that blue line. Remember, the height of our triangle is going to be the y-intercept of that blue line. So we need to start with the equation of that blue line. To get the x-intercept, we're going to use a 0 for y, and we can solve it for x. Now, here's where the trickiest part of this entire question comes into play. The distance from here to here is supposed to be a positive number, but this x-intercept is actually a negative number. So we're going to have to fix it by putting an additional negative in front of it. So we have negative and then negative b over m. So that will end up being positive b over m. And that's the only thing that we're going to do differently than we would if the triangle was on the right side in quadrant 1. Everything else will be the same. To get the y-intercept, you plug a 0 for x. So our y-intercept is going to be b. Again, our area function has m's in it and it has b's in it. We don't want to leave it like that or we might get stung. So we're going to get rid of the b's. We'll plug in our point. Our point is going to be -5, 2. And if we plug in -5, 2 into y equals mx plus b, we can solve it for b, and that will allow us to trade all the b's for 2 plus 5m. Now that the b's are gone, we won't get stung. So our area formula is going to be a function of m. And remember, we're trading all the b's for 2 plus 5m. Now we have the formula that we want to minimize, so we can plug it into our graphing calculator. We're going to plug it into y1. But remember, these are supposed to be functions of x. So instead of using the letter m, we're going to have to use the letter x. Then we'll go to the home screen and we'll solve where the derivative is 0. Okay, it's giving us two answers, 0.4 and -0.4. But now that we're on the left side, you notice the slope that we want is going to be a positive slope. So we're going to choose m equals positive 0.4. Remember, we're supposed to find the area. So we're going to plug this slope into our area function. Remember, our area function was stored in y1, so we're just going to do y1 of 0.4. Okay, our final answer is going to be 20. Okay, I'm going to have to explain this example here. You can see you're at the beach with your family. You went to the snack bar and you got a bunch of good snacks. And now you're going to walk back, but you want to get back as fast as you possibly can. You can walk on the road. On the road, your speed would be 8 feet per second on the road, so it's much faster than on the sand. If you cut through and start walking on the sand, your speed will only be 5 feet per second. But it will be a shorter distance. So what we're trying to figure out is what point should you start cutting across through the sand to get there in the fastest amount of time so that the food is not cold. you'll notice the total distance across is 2,000 feet. And then from the road to the sand, the total distance is 500 feet. Again, we want to get there in the minimum amount of time. So we're going to create a time function. The total time is going to equal the time on the road plus the time in the sand. Remember from physics, the distance is going to equal the rate times time. So if we solve this for time by dividing both sides by r, you get that time is equal to d over r. So each of these little times can be replaced with little d over little r. The easiest thing to plug in is always the rate. Those are given to you up top here. The rate for the road is 8 feet per second, and the rate for the sand is 5 feet per second. Now, if you look in the bottom over here, you can see that x plus d1 is 2,000. So if we subtract x from both sides, we get that d1 is 2,000 minus x. And d1 is the distance for the road, so we can replace the distance on the road for 2,000 minus x. To calculate the distance in the sand, we're going to have to use this right triangle right here. That would give us the equation x squared plus 500 squared is equal to d2 squared. Of course, we want to solve it for d2. We just need to do the square root on both sides, and that'll give us absolute value of d2 is the square root of x squared plus 500 squared. We can replace absolute value of d2 with plus or minus d2, and we can move the plus or minus over to the other side. And because the distance is supposed to be a positive distance, we'll just choose the positive one. It's the only one that makes sense. Okay, that is our d2, which is the distance in the sand. So we can replace our distance in the sand with the square root of x squared plus 500 squared. Okay, now we have our total time function. And now we want to minimize that function because we're looking for the minimum amount of time. So we can plug that into our graphing calculator. We'll type it in on y1. Then we can go to the home screen and solve where the derivative is 0. Okay, we're only getting one critical number. It's going to be 400.320. The reason I'm putting that 0 is to show that it's a rounded number. So make sure you do put that 0. Also, remember the units are going to be feet. And you want to make sure you answer the question. If the question asked you what the minimum time would be, then we would have to plug this critical number into our total time function. Now, if you did that, you would get 328.062 seconds. Now, for this question, I want you to notice that I deleted all the words because I needed more space to write. But basically what they wanted to know for this question was, how long do you walk along the road before you cut across through the sand? And so what they really were asking for was D1. Remember, D1 is going to be 2,000 minus X. This is our X, so we just want to do 2,000 minus that number. We can plug that in the calculator. There we go, 2,000 minus our X. We get 1599.6796. I prefer to truncate it, so I would go with 1599.679 feet. But you could also do 1599.680 feet. That would be acceptable as well. But if you wanted to get there in the fastest amount of time, that's how long you would walk on the road before cutting across through the sand